Today, we're going to tackle one of the most powerful concepts in programming, polymorphism. It's a core idea that really separates the good code from the great code. But here's the weird thing. It's built on a strange, almost backward idea. Let's dive in.
Yeah, that sounds totally nuts, right? How could not knowing what your code is actually doing possibly be a good thing? Well, this is the central puzzle of polymorphism. And by the end of this, you'll see exactly why this counterintuitive idea is so incredibly valuable. So that's the big question, isn't it? We're about to find out how intentionally forgetting details can lead to software that's way more flexible, way more robust, and just easier to manage. It really is one of the big secrets of great software design.
All right, to really get this, we've got to start with a concept that's kind of hiding in plain sight in pretty much every modern programming language. It's a fundamental building block that, once you really see it, makes everything else just click. And that secret weapon, it's the reference. This simple little idea of pointing at something, that's the absolute key that unlocks all the power of polymorphism. So what is a reference? Well, think of it like a remote control for your TV. The remote isn't the TV, right? Of course not. But it lets you control it. A reference is just like that. It isn't the actual object living in your computer's memory. It just points to it. Okay, now this slide. This is probably the most important idea we need to get today. Seriously. There's a huge difference between the reference type, think of that as the label we write in our code, like person, and the object type. That's the actual thing we create in memory, which might be a more specific employee. And here's the kicker. The label and the thing it points to, they don't have to be the same. And that right there is where all the magic starts.
So, because that label and the object can be different, we can do this really cool trick called upcasting. I kind of like to call it the art of forgetting.
It's actually super simple when you break it down. First, we create a really specific object, right? An employee. Second, we assign that employee to a variable with a more general label, a person label. And the result? Now our person reference is pointing to an employee object. We've basically chosen to forget all the nitty-gritty details about it being an employee, and we're just treating it like any old person. And this is so important to get. The actual employee object in memory hasn't changed one bit. It's still an employee with all its employee stuff. All we've changed is our perspective, the type of remote control we're using to interact with it.
So, you're probably thinking, but what if I need those employee details back? Well, you can try, and it's called downcasting. That's when you take that general person reference and you try to force it back into a more specific employee one.
But, and this is a huge but, doing this is often a red flag. It's usually a sign that you're fighting against your own design, and it just undoes all the cool flexibility we just gained. Remember our original puzzle? The real power comes from not knowing the specific type. It's all about forgetting those details, not desperately trying to get them back. Okay, enough theory. How does any of this stuff actually help us write better code? Let's look at a really classic example called the strategy pattern. It's like the perfect showcase for polymorphism out in the wild. So, picture this. We're building an audio player, but it needs to play all sorts of different files, right? MP3s, M4Vs, FLACs. The problem is, each of those formats needs a completely different algorithm to actually decode it. Without polymorphism, you'd probably end up with this giant, ugly chain of if-else statements. The poor audio player has to know the specific details for every single format, and if a new format comes out, you have to crack open the audio player's core code and add yet another else if. It's rigid, brittle, and a total pain to maintain. Now, look at the polymorphic solution. Oh, it's so much cleaner. The audio player just says, hey, give me something that can load this file. It gets an object back, but here's the thing. It only knows it as a generic track loader. It has no idea if it's an MP3 loader or a FLAC loader, and more importantly, it doesn't care. All it knows is that whatever it gets back, it's going to have a load method it can call, and that right there is the big win. Our audio player is now completely decoupled from the specific loading code. We could add a dozen new file formats, and we would never have to change a single line of code in the audio player itself. This is a core principle of great design. Our code is open for extension, but closed for modification. So let's zoom out. Why does this matter so much? Because this isn't just some clever programming trick. It's a fundamental shift in how we architect our software.
This powerful idea has a name, and it's one of the most famous principles in software design. Program to an interface, not an implementation. Our audio player didn't depend on the specific MP3 loader. It only depended on the general track loader contract, the promise that it would have a load method. And when you think this way, you get these three massive benefits. You get flexibility to add new behaviors without breaking your old code. You get decoupling, so different parts of your system don't need to know about each other's messy details. And you get reuse, because your core logic can work with any object that follows the rules. This brings us all the way back to our central idea. Polymorphism is more than just code. It's a powerful way of thinking. It's about focusing on capabilities, what something does, rather than its specific identity, what something is. And that's a concept that applies far beyond the world of programming.